So in this experiment, I'm going to use the least amount of wiring and show you how I can have the best output with earth grounding. So we have the 10-inch coil and the 8-inch coil, and I connected my single generator over here, and I'm going, so the red connection is for my single generator. I'm going through the capacitor, and then this capacitor is placed in parallel. So this is 1 microfarad and this is also 1 microfarad. Then at a certain distance of the L2 coil, I added over here a copper tube around it to make a capacitive coupling, but also a capacitor that is standing something further away from that wire. Now I'm going to show you the frequency that I'm working at the moment. We are working from battery power, so I don't have extra earth grounding from single generators part. So we are now working at the blue channel, so we are working at 4.11 megahertz, and we have 10 volts amplitude, and we have a sine wave input. Okay, so that is our input signal. So what I discovered is that when I create resonance, and this LED or a flamenco plug with LED is connected to earth ground. Now, when I come closer to that copper tube, the LED goes on. I will do it on the other side so the camera can also see it. So as you can see, the LED is already on. And the LED goes brighter the moment I touch that copper tube. But this has a negative influence when we look at the voltage output of our L2 coil. And what is the most interesting is when I touch this capacitor over here, the LED is much brighter than even with the copper tube. And mostly is because I don't influence the field of my L2 coil too much in this case. So when I connected my oscilloscope and I measured the signals, then when I come closer to this copper tube over here and I make my connection, then I'm also lowering the output of my L2 coil. But making the capacitive coupling at the right distance, I can have more output on this capacitor over here, but I have to have the right distance so that the amplitude of the L2 coil doesn't change that much, and then I can have the best output with earth grounding. Because this LED is now connected to earth grounding. When I disconnect earth grounding, you see that it even doesn't lit up. Just a very tiny bit. So it is the earth grounding connection that makes the difference. And how it is running at the moment. So you can see now the LED is on even when not touching the condenser there. So when I touch it, you see the amplitude, the brightness go up. And that is most important that I want to share in this video. The other side of my L2 coil is completely open, so it is just loose. And as you can see, also the LED on there. I'm going to put the camera. So disconnect ground connection. You see there is a little bit brightness, but the moment I touch it, we have more brightness. So now we are working from earth ground. Now what I discovered is that, and I can be wrong, so please let me know if I am, when we are using the voltage field, then the earth ground is the point where we get our gains, as you can see in the LED over here. And I didn't achieve the same result with the parallel tank circuit where I want to go to current setup. So I think at the moment that if we want to harvest from our L2 coil, that it is better to have a capacitive coupling, but it has to be on the right distance so that we don't influence our amplitude of the L2 coil. And we have a decent distance to have yet enough voltage, just like this capacitor over here. Because when I go closer with the capacitor, you see the amplitude go down. I will show you the distance with the camera. So as you can see, this is the distance at the moment between the two, and that is the right distance for my setup at this moment. And as you could see, I could light up the LED just from earth ground, and that is only succeeding when I'm using an electric field and not the magnetic. So please let me know if I'm wrong.